Hi students, today I am going to explain what are acids, bases and salts. So how we can recognize what are acids, what are bases and what are salts. So if you keep something food in your food in your mouth, we will observe that they will be sour, bitter tastes. If they are sour in taste, we can say that they are acids. If they are bitter in taste, like bases respectively. So if you are suffering from acidity, so by eating some oil food or something, so what we will do, we will take one antacid, or we can do one thing as a remedy. So we can add a lemon juice, vinegar or baking soda solution. So why this remedy is useful to us? So from this, what knowledge we are getting about the acids and bases and how to nullify its ability effect. So how to nullify the ability of acids and bases, these are all we will study in this chapter. So we all know that acids are sour in taste and they will change the color of blue litmus paper to red. So acids are sour in taste and they will convert the blue litmus paper to red. And reverse of this, bases are bitter in taste and it will change the color of red litmus paper to blue. So what is this litmus paper? What I am telling, it is an indicator. It is a natural indicator. It will indicate whether the substance is acid or base. Even turmeric is also one such indicator. So have you noticed the strain of a curry on white cloth? So in a white cloth, if some curry falls, it will become reddish brown when soap is added to it. So which is basic in nature. Soap is basic in nature. And it turns yellow again when the cloth is again washed with water. So much of water. Yes, no? So we can also use synthetic indicators such as methyl orange and phenolphthalein to test for acids and bases. Then here, litmus solution. It is a purple dye. So what is litmus solution? It is a purple dye which is extracted from a lichen, a plant belonging to the division Thylophyta. So this is the dye which is extracted from lichen, which is a plant belonging to division Thylophyta, and it is a commonly used as an indicator when the solution is neither acidic nor basic. If it is not acid or base, its color will be naturally purple. There are many other natural materials which are used as indicators like red cabbage, turmeric, colored petals of some flowers such as hydrangea, petunia, geranium, etc. So it will also indicate the acid or base. So all these are called acid base indicators, or simply we can call indicators. Then how we will understand the chemical properties of acids and bases? So I already told that acids are which taste? They are sour in taste and will convert red litmus to blue litmus to red litmus, and bases which are bitter in taste which convert red litmus to blue litmus. So if we take a sample solution and see here, so many solutions in the laboratory they gave. So we take that solution when red litmus paper is converted to blue litmus, or phenolphthalein solution, methyl orange solution. So it will indicate how it is converted and whether it is a acid or base. So these indicators will tell us whether substance is acidic or basic by change in color. Even they will change their order. What do you mean by order? Means smell. If they change by smell, if in acid it will give one specific order, and in base it will give one specific order, means smell. They are called olfactory indicators. Okay. Then onions, when we see when they are finely chopped onions in a plastic bag along with some strips of clean cloth, we will tie in a plastic cover onions and also cloth. After some time, leave overnight in the fridge, and morning you just test for acids and bases. Take 2 of these cloth strips and check their smell. If you see the smell, keep them on cloth surface and put a few drops of dilute hydrochloric acid on this one strip and few drops of dilute sodium hydroxide. This is HCl is acid and NaOH is base. So on the other, so we have to rinse both the cloth strips with water and again check their order. Now we will see observations. We will note the observations. Now take some dilute vanilla essence and clove oil and check their order also. So take some dilute HCl on one test tube and dilute NaOH, one acid and one base in another, and few drops of vanilla essence to both the test tubes and shake well. Check the order again. So and record again. Like this we can check. Similarly test the change in the order of clove oil and with dilute HCl. So the clove oil, how the order smell changes with acid and also with base, and record your observations. From this what you understand? Vanilla, onion, clove, these are all olfactory indicators. These are all basis of our observations because they are olfactory indicators, means they indicate whether it is acid or base by smell. Then how do acids and bases react with metals? Let's see how they react with metals, and this diagram is important. You should practice. Let's see. So when the acid reacts with metals, so what happens? Salt is formed along with hydrogen gas released. So here in this activity we saw sulfuric acid. Sulfuric acid here. See here sulfuric acid is produced. Sulfuric acid is in the test tube, and in this zinc granules are added. So when these are added in a test tube, so what happens in the delivery tube? So it is released, and here it is producing in the soap solution. They are producing bubbles. It is producing bubbles means it is hydrogen gas. It is checked whether it is a what gas it is, whether it is hydrogen or not. So when the hydrogen burning of hydrogen gas with a pop sound. So when candle is lit and placed here, it is producing pop sound. From this we can understand the hydrogen gas is released. Next, so what happens to bases when it is reacted with metals? So place a few pieces of granulated zinc metal in a test tube. So the same like before experiment, we keep some granulated zinc metal and add instead of sulfuric acid sodium hydroxide solution, and we have to warm the contents. So repeat the steps as in activity 2.3. So like in 2.3, so here we repeat the same activity. So what happens here also we can see the same hydrogen gas is released and sodium zincate is formed. So the reaction is sodium hydroxide, which is base, reacts with zinc, which is a solid, forms sodium zincate, which is a solid, and hydrogen gas released. So but for all the bases these reactions are not possible. So that's why they didn't give generalized reaction like acids. So we can see here clearly. So when the acids react with metals, it forms salts and hydrogen gas will be released. In base like sodium hydroxide, when metal like zinc is released and when it is warmed. So sodium zincate is formed and hydrogen gas is released. Then next, how the acids react with metal carbonates and hydrogen carbonates, or we can say bicarbonates also. Let's see first the general formula. Metal carbonates or bicarbonates reacts with acid to form salt plus carbon dioxide gas plus water. So how it is forming? Let's see the experiment here. So we have to take two test tubes. One is for metal carbonate and one more is for metal bicarbonate or hydrogen carbonate. So A for metal carbonate Na2CO3, we have to take 0.5 grams of sodium carbonate. In test tube B, 0.5 grams of sodium hydrogen carbonate or sodium bicarbonate. And for this first we have to add for A 2 ml of dilute HCl and for B also. So simultaneously we can do both the experiments. So A and B, 2 ml of dilute HCl we add, then we can see gas is released here, and we have to fix a delivery tube and it is to be filled in a test tube. So when it is filled in the test tube, and after that pass the gas that produced in each case through lime water. So we have to pass this in the lime water, so calcium hydroxide solution. So and we have to see what happens. Let's see. First in test tube A, what is there in the test tube A? Sodium carbonate. So in sodium carbonate is reacted with hydrochloric acid, so which is aqueous. Okay, so then what is formed? Sodium chloride, water plus carbon dioxide gas released. So the sodium carbonate is a solid. So in this liquid aqueous form of hydrochloric acid, so that sodium chloride, which is aqueous form, is formed, and water liquid form is formed, carbon dioxide released, which is passed into the test tube. In second case also, sodium bicarbonate reacted with hydrochloric acid. The same sodium chloride, water and carbon dioxide are formed. The equations are balanced, as you see. Then when the carbon dioxide gas is passed into the test tube and calcium hydroxide solution, that is lime water. So when the gas is passed into the calcium hydroxide solution, then we can see a white precipitate is formed. That is nothing but calcium carbonate. So when more gas is like that only passed into that, then the calcium carbonate again reacts with water and carbon dioxide in this, and it will form calcium bicarbonate, CaHCO3 twice, which is aqueous and it is soluble in water. Limestone, chalk and marble are the different forms of this calcium carbonate. So all the metal carbonates and hydrogen carbonates react with acids to form corresponding salt, carbon dioxide and water. I already told the general formula of this. Like this we can. Next, how do acids and bases react with each other? What happens when acids and bases react with each other? First we will see the general formula. When acids react with bases, what happens? When base plus acid is equal to salt plus water. So both acids and bases react to form salt and water. Let's see the experiment. So take about 2 ml of dilute NaOH solution in a test tube. In one test tube, take 2 ml of dilute NaOH solution and add 2 drops of phenolphthalein solution. So we have to add phenolphthalein solution, which is an indicator. So what is the color of the solution? Let's see. And add dilute HCl to the above solution drop by drop. So any color change in the color, we can see the change in the color. Why did the color of phenolphthalein change after the addition of acid? After we add acid, the change will be there in the color. So it will before it will be pinkish in color. So when phenolphthalein is added, it will be pink in color. So after we add acid, this pink color disappears. Does the pink color of phenolphthalein reappear? So again, how it will appear? Again, we by adding some base. So here in this activity, we have observed that effect of a base is nullified by an acid. The base effect will be made zero. Nullified means made zero by some acid or by adding again So or we can make it vice versa. So the reaction how it took place: sodium hydroxide, which is a base, and hydrochloric acid, it is an acid. So both reacted to form NaCl plus H2O. We can see here one reaction. What is that? Displacement reaction, double displacement reaction. The reaction between acid and base will give salt and water, and this reaction is called neutralization reaction. What it is called? Neutralization reaction. In the exam, if they ask what is neutralization reaction, you should write this only. Then reaction of metallic oxides with acids. So when the metallic oxides react with acid, then salt and water is formed, as metallic oxide is acting like a base. So like in neutralization reaction, base plus acid is equal to salt plus water. Same in this case also, metallic oxide reacting with acid to give salt and water. It is called basic oxide. Metallic oxide is also called basic oxide. Then we can see reaction of non-metallic oxide with base. So we saw the reaction between carbon dioxide and calcium hydroxide in the first experiment. Here calcium hydroxide is a base. It is reacting with carbon dioxide to produce salt and water. Since this is the reaction between a base and acid, we can say that metallic oxides are acidic in nature. So non-metallic oxides are acidic in nature. So we told that metal oxide are basic in nature and non-metallic oxides are acidic in nature. Remember this. Acidic oxides or they are acidic in nature. So metallic oxides are basic oxides, non-metallic oxides are acidic oxides. That's all.